hope you guys are all doing well. Today we are going to look at trigonometric identities. These I kind of see as a puzzle that you have to solve. They can be a little bit tricky just because each one is going to be unique. So like I could show you example after example and you'll still come across one that will be different. And because of that, you do just kind of have to work through them. And they require a little bit of thought, but I kind of think they're fun. A lot of kids hate them, but then at the same time think they're kind of fun to do. So what we're going to be doing is proving that an identity is true. So in order to prove that an identity is true, we have to treat it a little bit different than an equation. So I have that right here. Proving an identity is different than solving an equation. So we'll use kind of the same techniques, but we're not going to be solving for anything. So an identity is an equation or statement that is always true, no matter what. So in trig, for instance, one of our identities is that sine is equal to 1 over cosecant. And so to prove an identity, what we're going to do is we're going to use logical steps to show that one side of the equation can be transformed into the other side of the equation. You do not plug values in to prove anything, so we're not like plugging anything in for x or trying to find like something on the unit circle like we have in past sections. There are going to be infinitely many things that you could plug in, so that doesn't actually prove anything. So what we're going to do is we're going to be looking at each side and trying to show that they can become the same thing. So to prove an identity, the tricky thing is you cannot work from both sides at the same time. You can only work on one side of the equation. So we're going to be picking either the left side or the right side of the equation to look at. So when we are doing this, if you work on both sides, it doesn't actually work out. That doesn't prove anything. So you can only work on one side at a time in order to actually prove that one side equals the other side. So since we'll be working with two different sides, you'll see sometimes people will label like the left-hand side as LHS or the right-hand side is written as RHS. I usually don't do that just because I'm lazy and I don't write things I don't have to, but if you ever look at other notes or Google something, you might see that notation come up. But in order to prove all these different identities, you are going to need to know these main identities that we're looking at. So the quotient identities are coming from tangent and cotangent. We've already talked before how tangent is sine over cosine. And then since cotangent is the reciprocal of tangent, it's just the flipped version of that. So we have cosine over sine. The reciprocal identities, we've talked about these a little bit as well. Cosecant is equal to 1 over sine. Secant is 1 over cosine. And then cotangent is 1 over tangent. I don't really like using this one though. I'm going to cross that one out. Sometimes students get hung up on this one and try to use this when you actually probably want to use this version for cotangent instead. This one works better. So I wouldn't use the 1 over tangent version. And then these are the new ones that you guys haven't seen before. These are the Pythagorean identities. So the first one is that sine squared plus cosine squared is equal to 1. This one is a really common one that you will use quite a bit, especially if you go into calculus next year. You'll see that one a lot. We also have that 1 plus tangent squared is equal to secant squared, and then 1 plus cotangent squared is equal to cosecant squared. So we are going to be using these to help us prove these different trig identities. So let's look at some examples. So when you are proving an identity, you're going to be given an equation. Again, the tricky thing with these is each one's going to be unique, so you have to be kind of careful with how you approach it, and then you just have to kind of think your way through it. Sometimes it can be kind of tricky. So if they seem really hard at first, don't feel bad, because that's really normal to see these and get kind of confused by them. But What I like to do is I pick the side I'm going to work with, and you want to pick the more difficult side. It's going to be easier to simplify the harder side to turn into the easier one than it would be to take the easier side and turn it into the harder side. Because again, what we're doing is we're picking one side, and I want to show that this can turn into the other side. So I like to pick the more complicated side. And then I also, so step one is we're going to pick a side to work with. And then the next thing I like to do is I like to turn everything into a sine or a cosine. So that is going to come from those different identities that we know. So like if I have a cotangent, I want to write it instead of as cotangent, I want to write it as cosine over sine. Or if I have a cosecant, I want to turn it into 1 over sine. I want to get everything into a sine or cosine version. So I'm going to pick this side, the left-hand side, and I want to show that this left side can turn into cosine. So by doing that, I'm going to change each of these, the cotangent and the cosecant, into its sine or cosine version. So I know that cotangent is equal to cosine over sine. I also know that cosecant is equal to 1 over sine. So knowing this, I'm going to replace both of these versions into this fraction. So instead of cotangent, I'm going to write cosine over sine. But then this is being divided with our cosecant on the bottom. But instead of cosecant, I'm going to turn that into 1 over sine. So we have one of those lovely fractions being divided by a fraction. But remember, that's just one way to make it look kind of scary. But we can rewrite that by doing keep it, switch it, flip it. So I'm going to keep the top fraction as cosine over sine, change it to a multiplication, and then flip this to the reciprocal. So I get sine over 1. But then now we see that this sign on the denominator cancels with the sign on the top, and I just get cosine over 1 if I times those, which is just equal to cosine. And really I should probably be putting the x's in through here, but I'm lazy and I always forget to write those. So we just showed that this side equals cosine, which is what we were looking for. So we just proved that cosine is the same as this, so you can write it both ways. So that's how an identity works. Again, you pick a side to work with. We're only going to look at that left side, and we want to try and turn that left side into the right side. And again, I like to take anything that isn't a cosine or a sine and turn it into the version that is. Okay, so that one is I would say an easy one. Let's look at a harder one. So on this one, we have cotangent plus tangent equals secant times cosecant. So I told you to pick the harder sides. Sometimes both sides look kind of hard. In this scenario, I do think that the addition is harder to work with than the multiplication. So I probably pick this side to start working out with. And so we are trying to show that this side is the same as this. So it still is going to work where we want to try and change everything to be a sine or a cosine version. So cotangent, again, we know that cotangent is the same as cosine. I'll write my x's this time, over sine. And then tangent, we know, is the reciprocal of that. Tangent is sine over cosine. And we want to see if we can turn it into this side. So right now, I have two additions with a fraction, right? But I can't add these fractions right now because I don't have a common denominator. So we are going to get that common denominator. I have a sine and a cosine. I can't turn sine into cosine. I can't turn cosine into sine. So to get a common denominator, we're just going to have to times it by each piece. But if I times the bottom, I have to times the top. So I'm going to have to times this side by sine. So they both have a sine and a cosine. So that if I times these through, I get cosine times cosine is cosine squared. And then now on the bottom, I just have cosine times sine. And then on this one, I get sine times sine gives us sine squared. And then on the bottom I have cosine times sine. And now that I have that common denominator, I can add these. So on the bottom, we just have our common denominator, cosine times sine. And it gets super annoying writing these over and over and over again. But then on the top, you get cosine squared plus sine squared. So just kind of a hint, whenever you see squares in these, it's probably a pretty good sign that it's going to be one of these Pythagorean identities. This happens to be that main one that I put the star by that you'll see the most often. That sine squared plus cosine squared is equal to 1. That's one of our identities. So this whole thing just equals 1. So I can replace that with a 1 on the top. So I have 1 over cosine times sine. But if we look at our initial identity, we wanted to turn it into secant and cosecant. Well, if I split this into two fractions and I write this as 1 over cosine times 1 over sine, which is still the same thing, right? I'm just kind of being a little tricky here. 1 over cosine, that is the same as secant. And 1 over sine is the same as cosecant. So we just showed that this half of the identity I can turn into the right side of the identity. So we are good, and that would be kind of your final check. So again, those are your identities. They can be kind of tricky just because they literally are all different. So I could show you example after example after example, and there still would be one on your homework that would maybe throw you for a curveball. We will spend some more time practicing these, so if they still feel kind of tricky, don't feel bad, that's kind of normal. But you will want to probably write these different identities down, so maybe pause it really quick and write these down so that you have them as you're working through. And then if you guys have any questions, again, you can always email me, and then we'll probably do another Zoom meeting later this week, and we can go over some more together if you want as a class. So keep an eye out for that Zoom meeting notification probably on Friday again. And then I will just get back on and show you guys some more examples next time. But let me know if you have any questions, and I hope you guys are all doing well. Just head to Math Excel for your homework. See ya!